Hello. Hi. Thank you, everybody, for coming today. So yeah, let's get started right away. This title you see here is actually inspired or even copied from an Alter Security blog post that I saw a few months back. And they had sort of a whole blog post on how you could bypass EDRs using custom callbacks. So that got me thinking on how we could do that potentially with Minifilters. So yeah, let's get to it. Quick intro, who am I? My name is Tom. I'm French, but I live in London now. I'm working in incident response, but that's actually a fairly recent switch. Up until September, I was in offensive security. That's where I spent pretty much my whole career up until 2 months ago. So yeah, I've mentioned here on this slide that this is my first major conference talk. So a little bit anxious, you might be able to tell. But I'll definitely be looking for some feedback at the end of it. If you have some, there'll be a Q&A session as well. So yeah, if you have anything, really looking forward to hear that. Then on the agenda for today, we'll start with a bit of background on EDRs, like what components are involved in EDRs, how they work together, but specifically we'll focus a bit more on the Minifilters because that's what we're here for. In the second part, we'll cover a few old and more recent attacks involving Minifilters. Then we get to the main juicy stuff, the main technical part where we see how we can actually turn things around on the EDR and use Minifilters against them. And finally, we'll see, I guess, a bit how, as defenders, we could prevent that from happening or detect it at least. So, diving right in, the EDR agent. First, let's look at all the blue elements we have here. These are, I would say, broadly speaking, the elements that make up your operating system. So you have your file system to manage your files on the left side. You have your network stack for communication on the right top side. You have images and processes to execute code. So that really makes up, in high-level terms, your operating system. In orange, you have the elements that the operating system makes available to the EDR for security purposes. So you have the ETW, event tracing for Windows, which just provides some logging, basically, and the EDR can consume this log source and analyze these logs to, or maybe correlate them with some other telemetry sources they have to discover malicious behavior. And you have the ELAM service on the right side, which is the early launch anti-malware, which allows pretty much to load the ELAM driver that's right above it before most drivers on the system for anti-malware purposes. 9 red, we have our juicy stuff. We have the actual EDR elements. Not all of them are actually implemented by all EDR vendors, but I would say most EDR vendors implement most of them because, well, the more security features you have, usually the better. Starting with, obviously, the Minifilter, the file system Minifilter on the left side, which allows to monitor the file system for events and will be the main focus of today. Next to it, we have the static scanner. Pretty, I would say, a common functionality. You just scan files. Yes or no, is it malicious? That's what it does. Next to the static scanner, we have the kernel mode driver and the hooking DLL. These two work together to sort of try and detect some maliciousness whenever Windows APIs are called. Obviously, the kernel mode driver also has a lot more security purposes for monitoring things like image creations, process creations, these type of things. But we won't go into too much detail. Next to it, network filter, similar to the file system Minifilter. You have the equivalent for network. And then finally, at the very bottom, you have the agent service. I would say this is probably the most crucial piece of the EDR because its role is really to aggregate all the telemetry created by all the other sources that are there. And sometimes it does more than that. It might contain, maybe a machine learning module. It might correlate events, generate alerts, these type of things. But it's generally where all the I would say it's the main service that will ship the logs to, let's say, your data lake or your EDR provider or wherever remote server you have to ship those logs to. So it's really the central piece of the EDR and if this whole architecture really, without it, you pretty much have no EDR on your endpoint. So let's dive a bit into Minifilters. Put it shortly, a Minifilter attaches to the file system stack. So they're just kernel drivers that sit between user land, where you and I just interact with the file system, create files, open them, these kind of things, and the actual file system that will perform the operation. So what you see on the screen here is an IO stack for the filter manager, which in a nutshell is the system that allows developers to write Minifilters and to have them executed on the system. What it means really is any developer can create their own Minifilter driver, install it on their machine, and then start filtering event. So whenever you have a user who tries to open a file, if your Minifilter filters for that specific event, then you can take action on that specific file opening event. So yeah, it can be as simple as that. And what it's commonly used for, well, obviously, most interesting use case for us is the first one here, where you have file being scanned by the EDR before, for instance, the file being executed, and it's one of the main reasons why EDRs implement Minifilters actually. But they can also have other usage. They can just collect data that can be used again for security purposes, metadata, such as, well, events on file creation, file deletions, these type of things. It's a really good source of truth because you're sitting at a fairly low level in the system. You're already in the kernel. So there are other solutions that can do that in userland, but you're here much closer to what really happens on the file system than with these other solutions. And yeah, Minifilters have also other usage in backup agents or file encryption, decryption agents, for instance, but not really a concern for us today. A very important point that we need to touch on before we get to the really juicy stuff is altitude. I bring this up because it'll be used in some of the attacks that we see afterwards. So each Minifilter must have a distinct altitude. This altitude is just literally a value that defines the order in which each Minifilter is executed on the system if you have multiple Minifilters that are registered. They are given by Microsoft to the vendors. So if you're an EDR provider, you request an altitude from Microsoft, they'll check you're legit, give you one altitude value, and then you need to use that in your Minifilter driver. But really, why do we need this concept? It's because the filter manager needs to know which Minifilter executes first when multiple Minifilters are registered. So there are really two orders that matter. First one is the pre-operation callback order. Second one is the post-operation callback. So whenever you have an event, file system event, this filter manager will intercept that file operation and will intercept it sort of twice. Once before it's completed, so that's the pre-operation callback, and once after it's completed, that's the post-operation callback. And the order in which these callbacks are executed depends on the altitude. So Minifilters with a higher altitude simply have higher priority on the pre-operation, and Minifilters with a lower altitude have higher priority on the post-operations. And I think with that, we've covered everything to see our first attack. First thing, Minifilter onloading. You could argue that's not really an attack, and I would kind of agree with you, but this is probably the surest way of evading Minifilters in a system. Simply remove them, unload them. So this fltmc.exe is a command that's provided by Microsoft to manage Minifilters in general, and it has an option to simply unload Minifilters from the filter manager. So that's pretty convenient as an attacker, because once that link is severed, well, filter manager doesn't pass execution to that Minifilter anymore. So if you're unloading an EDR's Minifilter, most likely they won't really look at your files anymore, at least from the Minifilter's perspective. But there are a few catches. First one is it requires some specific privileges, this SC loader driver privilege. You may know if you have this privilege, chances are you're already admin or system on the machine, so it's not that easy to get. Second, EDR providers might also try to hide their Minifilters by giving them some sort of random names rather than just naming it, hey, Microsoft EDR Minifilter. Overall, an attacker would still be able to find those, but requires a bit more effort. And third, the unloading event does generate some noise. Specifically, you have an event ID number 1 generated by the filter manager for this. So if you monitor that, you might be detected. Second attack here is altitude sickness. So the first time I saw this technique, it was actually introduced in a blog post again by Tier 0 Security. And the principle is actually very, very simple. We've seen before that each minifilter needs to have a unique altitude value to define the order in which they are called. But what we did not talk about is what would happen if two minifilters had the same value. Because these altitudes are just values that are set in the registry of each minifilter. If we have two minifilters, nothing prevents us from changing one value to the other. And this is exactly what the researcher from Tier 0 Security did. On the left side of the screen, we have two minifilters of interest. There's a value that's backed out here. It's actually a well-known EDR, so for, I'd say, respect purposes, we didn't put it on the presentation. And then we have the sysmon driver. Then what the researcher from Tier 0 did is just change the sysmon altitude value to that of the EDR's minifilter and reboot. And after that, we see that the EDR's minifilter is simply gone. Reason is, at boot time, it couldn't register because the altitude value was already taken. Now, a question you might have on this is, why was the EDR's minifilter not loaded instead of the sysmon driver? Because finally, we have those two minifilters, they have the same value in the same altitude. Why is one taking precedence over the other? Answer, I would say short answer is, the altitude is not the only minifilter setting that affects the load order. So you have this thing called the load order group. Microsoft has a nice documentation on this, and you see actually on the side right here, the infrastructure one is the one that loads first. So if your minifilter is part of that load order group, while the EDR's minifilter is not, chances are yours will load first. Same goes for the start type and service type. These are all parameters that we can play with to have our minifilter load before, or at least if we're using an existing minifilter that's already present on the system, or let's say a kernel driver that's already present on the system, we can look at these parameters to select the proper one to play with. Next attack is a bit more interesting, is bring your own minifilter. So what you see on the screen here is the textbook official Microsoft documentation, which is sort of giving us a roadmap on minifilter evasion with the FLT pre-op complete value. So what it's telling us is, if we return the specific value during one of those pre-operation callback, none of the minifilters below will be executed for that processed event. So let's be a bit more visual about this. If we could take a look at that filter manager again, the definition we just saw just means that if I manage to register my own minifilter, I can write logic to return this pre-op complete on all the files that are of interest to me, for instance, mimikatz.exe or whatever other executable I have. Then any file system event involving these files will now be completed at my minifilter level only and will not be passed down to the EDR's minifilter. So that simply prevents the EDR's minifilter from intercepting any file system operation on my specific files. You might have already noticed, though, you need two things for this to work. First, you need to register your own minifilter, and we'll see later on there's plenty of prevention and detection opportunities for this. And you also need your minifilter to be high enough in the chain. It needs to be higher than the EDR's own minifilter. So we need a high altitude here, which is also sort of a red flag. So if we rewind a little bit, we just covered this bring your own minifilter attack, which relies on that completion of operation for whitelisted files. In this attack, we have our own minifilter. We detect events involving our own malicious files. We whitelist them so they're not passed on to the EDR. And that works as expected, but it's also not super practical because any new file that we want to whitelist, we need to recompile our driver, we need to reload it, we need to reboot the machine. So that's a lot of events, and that's a lot of detection opportunities. In general, from a blue team and good security perspective, we want to deny everything by default and whitelist only the known good. And that's good practice. But from a red team perspective, we'd much rather like if it's the other way around, where we have everything allowed by default, because that's where we find the juicy stuff. That's where we have the misconfiguration, the edge cases that sort of allow us to slip through. So what if we flip this attack and sort of did the opposite? Instead of whitelisting known bad, we just blacklist known good. And that's the idea of this sort of revisited version. Theory behind it is also quite simple. Minifilters are the intersection between userland and the file system. So similar to before, we can just control what is passed on, and we can control access to the file system. The attack here uses exactly that principle. We register a Minifilter, but instead of using an allow list for the files we want to slip through, specifically, we attack the EDR itself and the EDR files. So the pseudocode on the right here is pretty straightforward. We have a blacklist of EDR-related executables, and if any action is attempted on them, we deny that action and simply complete the callback operation. And that has another major advantage as well. The altitude can be as high as we want here or as low as we want, because we don't need to complete these operations before the EDR's own Minifilter, because we're targeting non-malicious files. We're targeting the EDR's files and simply deny access to them, so that when the EDR boots up, it tries to access those files to load its agent and simply can't. So our full attack chain looks like this. At first, we have a new system. It's untouched. The EDR is running. We don't have any Minifilter. Everything looks good. Second step, we prepare the attack. We need to register our Minifilter. So we need to obviously develop it, register it. Once we have that, we reboot our system so that our Minifilter can load. And once we load, the Minifilter starts obviously filtering events. And when the EDR tries to start its service, it tries to go to its executable, tries to load that image. Minifilter says no. So no image load means no EDR service, means, well, pretty much no EDR agent running at all on the system. And that's step 5, where the agent service is not running anymore. So from a technical perspective, let's get a bit into the details. First step really is to tell our filter manager that, hey, I have a new Minifilter that you now need to take into account. And this is actually what is done on the top function here, top left, with the FLT register filter function. To do that, we need a filter registration object, and to create that filter registration object, we first need to define what callbacks our Minifilter will handle. So on the right side here, we see 2 elements in the callbacks array. I'll start with the second one because it's the easiest one. It's just here because Microsoft specifies in their documentation that every callback array must have this operation and value at the end, so that's the only reason really it's there. Now, more interestingly, the first element has 4 sub-elements. First argument is probably the most important. It's that RIP MJ create. It's the value that says we want to intercept any file system event that is when a file handle is created. So that happens when you try to access a file, that happens when you try to create a file. Pretty much all major file operations require that event to be triggered. So for us, that's very juicy because it pretty much allows us to intercept everything. Second argument is not used in our case, and third argument is very crucial as well, because that's a pointer to our own function that will be executed during that callback. So this is where we define our logic to deny the files. Last element is null. It could be also a post-operation callback, but we don't need it in that case. So now we're getting to the crux of it. This is our actual logic that will be implemented here. If we recall earlier, we said the objective was to blacklist EDR-related files. So that's exactly what we do. On line 6 and 7 here, we just ignore a few parameters because we don't use them. On line 8, we define sort of a default status variable. So when the events involve files that are not the EDR-related files, this is what we return, which is written pretty much most of the time, actually. And we also ignore kernel mode callers because we just want to prevent the EDR processes from starting at all. We want to prevent the EDR from accessing its own executable, but this can be done directly in userland. We don't need to worry about kernel mode drivers for that. And then we have at the very bottom, line 16 to 18, we define a constant, an array. This is all the files that we want to deny the access to. So in this example here, I just have test.exe, but we'll see in the demo later, have actually defenders related files. So we'll see how we can prevent defender from starting. Last piece of code, probably the most straightforward code of this presentation. On line 4, we get the file name information from the data that is passed to us via our callback. On line 6, we parse it. I'm passing on the details of why we need to do that. Microsoft's documentation is very clear, but we simply need to get the file name pretty much. And then we iterate over our array of files that we want to block, and if we have a match with the current file that is being processed, then we deny access. Otherwise, we'll just return the default value. And in terms of technical stuff, that's pretty much it. So just a quick recap before we move on to the demo. In short, this attack works by adding a new Minifilter and ensure it executes on every file access operation. Then on each of those operations, we use the Minifilter logic to compare the file name to known files that we want to deny access to. And if we have a match, deny access to the file. That's pretty much all you know really to understand the POC, which is available on GitHub. I should have actually included the link, but I can share that, I don't know, maybe afterwards and add in the presentation. And if we think about next steps here, we've covered sort of the whitelisting of known malicious files. We've covered the blacklisting of known good files, but we could potentially combine both. That might bring some robustness to the attack. But I have not tried it just yet, so it's sort of open for the reader to do this exercise, but could be worth a shot. Now, demo time. All right. Let me see if I can have my VM pop up. Okay. Sorry, it might take a little while to load. Would that work? Yes. So in this demo, we'll actually proceed in 2 steps. First, we'll just see that we have the code for our Minifilters. Then we'll see how we can sort of make sure that our Minifilter actually denies access to the file by All right. Let's see if I can show you guys the code in Visual Studio first. That might take a while to load. So in the meantime, let me just get the command prompt. Of course, I didn't mention that, but you do need administrator privileges because, first of all, you need to load your driver. In my case, it's an unsigned one because, well, I didn't pay and go to Microsoft to tell them, hey, I want to sign some kernel exploit type of things. So you need to turn the machine into test mode and allow unsigned drivers to be loaded, which is kind of a red flag also for that attack. And then you still need to load things into the kernel. So obviously you need administrator rights for this. You might have noticed here the name of the project is Null Filter, because actually I didn't write this from scratch. Microsoft has a pretty cool sort of Git repo of all possible filters that you can write, and I just reused one of their examples. But if we have a look here at the juicy part, we have obviously our tests.txt file here that we'll do some experiment with at first. And then we have all these files here that are related to actually Elastic and Defender. You could have a lot of other EDRs here. I don't foresee any EDR really having any other, let's say, issue with this, simply because we're preventing the process from starting, so there's really not much they can do in the first place. And yeah, I've already precompiled that for demo purposes. We all know how it goes. And let's get to it. So at first I have, let me put this away. I have my test.txt. Normally I should be able to access it right now. You see me. And if everything goes well, in a short moment, we won't be able to see that anymore. All right, so first operation here, we're simply creating a service for Minifilter. The start type is on demand, so it's not at boot time just yet. I need to start it manually, and it simply uses using the Minifilter, the compiled version of that Minifilter, obviously, to create the service. There are a few registry keys we need to import. It's mostly actually the altitude that we need to set. So that's what we're doing here. And now, if I start that Minifilter, Let me just make sure that the test.txt is closed. Yes. It has started, and test.txt should not be accessible anymore because we're simply denying access to that file. All right, let me now stop the service. Delete it. And we will now recreate it, but this time we will make it start at system. All right. And we need to still import the registry keys. Without this registry key, you'll get a blue screen. I experienced that yesterday, literally, when I was trying to prepare that demo. Not fun. All right. And now all we have to do is reboot. At next boot time, our Minifilter should be applied, and the EDR should be simply not running. So before that, let's just make sure that Defender is actually running. So you guys can see I'm not doing any shady things. Yeah, we have real-time protection on. If we check Process Explorer as well, we should be able to see, I believe it's MSMP. Yeah, we can see the MSMP ng-exe process running. And now I will simply reboot. Fingers crossed, no blue screen. Okay, we've passed the most. And now let me have a look at the same Process Explorer and see if this MSMP is there. It is not. So it looks like it worked. And if we take a look at Defender, I believe it'll just say loading status for a little while. Yeah, getting protection info. If we wait 5 to 10 minutes, it should show up as nothing's running. But actually, it's pretty much disabled. Let me see. I have a Mimicat here. We can try and execute it. All right, just copying this to desktop, and then another CMD. And we're in. So, yeah, EDR is disabled. Everything works sort of as expected. That's pretty much the extent of this demo. Can I go back here and continue presenting from the current slide? All right, cool. Okay, so how can we prevent that from happening? We saw earlier unloading is the simplest way to get rid of a Minifilter, but it's also the easiest one to prevent and detect. First of all, requires that SE load driver privilege, not something really any user should have. Of course, you always have the problem of privilege escalation. So if you have an attacker who escalates to system, then you can't really prevent this, right? But that's true across pretty much all of the attacks that we've seen today. The detection is also as easy as simply checking for the use of this fltmc.exe, specifically with that unload argument. But there are two problems with that approach as well. First one, command line obfuscation is a real thing. There are like 1,000 ways you could write that same command, and at least as far as I know, no EDR is just capable of catching them all right now. And the second one is actually the filter unload function. So this Win32 API that can also be used. So an attacker could just write their own little program, the language of their choice, use this function and get really the same result. The only sort of detection point that we have there is the use of the, or at least detection for prevention purposes, is to monitor the use of the fltlib.dll, which is where that filter unload function is defined. But again, a few problems here. A lot of legit programs use that DLL, so lots of false positives, and the list of DLLs that are loaded into a process could also be faked. Or rather, like an attacker could try and resolve DLL dynamically and so on. There's a lot of techniques like that out there. So also lots of false negatives potentially. So yeah, not a really great start for us on this point. Second attack that we saw was the altitude sickness. So if we recall this attack, the whole technique relies on the fact that we know the EDR's minifilter altitude beforehand, and we register another driver at the same altitude, effectively preventing the EDR's minifilter from loading in the first place. To counter this, EDR vendors now generate the altitude dynamically at boot time. So instead of a fixed altitude value, it still uses that fixed sort of integer part that is given by Microsoft, but EDR vendors now add a 5-digit decimal part that is totally random and generated at load time. So that prevents us pretty much from setting the same altitude as the EDR's minifilter, because we would have to guess those random 5 digits. And we could try and brute force it, but you need to reboot every time. So 1,000 reboots or 100,000 reboots, you need to have a long time. And as far as I know, there's no bypasses available at this time, so we're good on that point. Now, going back this time on our BYOM attack. The basis of the attack is you register your own minifilter at a higher altitude than the EDRs, and then you prevent all file operations from reaching that EDR's minifilter, at least for your files of interest. So let's see what IOCs we can use to detect this. First thing, if an attacker develops their own minifilter, and we've touched a little bit base on that, most likely they won't be able to sign it. So, well, good thing to do is not allow any unsigned driver to be loaded. Easy enough, because Microsoft doesn't allow it by default. So, good point there. But stolen certificates are a thing. We've seen attacks with that before. So you might still be able to have sort of unlegitimate but signed driver that you could load that way. And system, again, is always going to be a problem. With system rights, you can disable signature enforcement and load unsigned drivers, which is pretty much what I did in the demo. And you can also potentially install your own certificate authority on the machine, then self-sign the driver. So lots of bypasses possible here, even if the machine doesn't allow unsigned certificates. But that gives us a few opportunities for detection as well. First is the altitude. So with that non-revisited version of the BYOM, you need high enough altitude, and higher than the EDR's minifilter actually, because you need to obviously have the events reach you before the EDRs. But there's little to none legitimate use cases of that, especially for unsigned driver. So that's a big red flag if a minifilter driver is loaded at a higher altitude than the EDR. Then we've seen to load unsigned drivers, you need to disable integrity checks and enable test mode, so we can detect those comments here. There's a service creation command as well, probably a good point for detection. And the commands also to enable test mode, load the service, and so on, they result in changes in the registry. For instance, you have the altitude that is set when you create a new minifilter, but also for the driver signature verification, this is all registry changes that we can detect. So, yeah, a lot of opportunities for us here. Finally, in our revisited version, what could we detect? Well, we just saw we need to import our own driver in this attack too, so all the opportunities for detection that we just saw still apply, minus, of course, the altitude. It's not a factor anymore, because with that revisited version, the altitude can be as low as we want, since we don't need to go before the EDR's minifilter at all. Actually, in the demo, the altitude literally was 0, so that works pretty well. And last point here is this new version shuts down the EDR agent itself. All the other attacks that we've seen before, they shut down the minifilter portion of the EDR. So you could still have other sources of telemetry. Here, you have the EDR agent that's not starting. So if you're not preventing directly any of these events that we've seen where you need to load the minifilter, you won't receive any telemetry anymore. So you won't have all these other opportunities for detection after that. So just something to be mindful about. And yeah, I think that wraps it up. Any questions? Thank you.
Hi, thanks, good talk. You said that you need to disable the signing requirements on Windows, and you had to reboot it after enabling it as a to start or to be loaded on the system. Reboot, so it's loaded first. Does that mean that to exploit this, you're going to have to actually reboot the system twice? Do you need to reboot it once after disabling the signing requirements and then once after configuring it to be loaded?
Yes. So if you're putting the system in test mode, you actually need to reboot it twice. If you use any of the other options, like if you have somehow a stolen certificate that you're able to use, you only need to reboot once. But yeah, you're correct.
Thanks, it was great talk. I want to know, like, as EDRs, provider has something called as blocking mode, where they prevent their processes to be not touched. Let's say at the moment you're unloading EDR process. At that point in time, like where they don't let you open a handle towards the EDR process. How does it work? All of this attack with those kind of EDR protections.
Yeah. So actually, this is sort of even different than the sort of opening handle process mechanism that you mentioned, because here we're preventing the EDR from starting up in the first place. So when you reboot the machine after loading your Minifilter, one of the first things that the EDR wants to do is look at the .exe, at the EDR image, and start the service so they can start taking all sorts of action on the system, right, and protecting and, for instance, putting in place the protections that you were just talking about right now. But here we're preventing that from happening in the first place by simply denying access to the exe that is needed for the EDR process to spin up in the first place. So you won't have an EDR process that is spin up at all. So you don't sort of need to create a handle to it or affect it in any way because it's just not created in the first place.
Tom, really thanks for the talk, but all the time I'm listening about awaiting EDRs. My first question is, if manufacturer already got local system, why to bother deploying Minifilter? They could stop even self-protecting service at once, right? Maybe you could argue and give me some arguments not to just stop.
Sorry, actually, it's really low volume. I wasn't able to hear.
Not loud enough, sorry.
So could you repeat the question?
Sure.
Thank you.
If a manufacturer already got local system account, administrative account, why for them bother to deploy any Minifilter and not just stop with the same SC utility, the stop self-protecting service for the EDR?
I'm really sorry, I don't think I understood. I'm sorry.
Sorry for that.
Maybe we can talk about it right after. All right. Any other question? Yeah, I see one right there.
Is there anything stopping EDR from whitelisting itself? Could they have a higher altitude?
So, yeah, actually, potentially they could implement that same sort of BYOM technique that we've done, where if anything's trying to touch the EDR files, we allow it and then we complete the operation so no one else can do anything about it. They could do that. To my knowledge, they don't. And then you could also prevent that from having beat the EDR their own game there by, again, registering the higher altitude. But that comes also with a set of red flags because that altitude then is potentially detected. No problem. Anything else? All right. right, I think that's it. Well, thank you very much for coming. And yeah, any comment, feedback, I really appreciate it. That was my first time. Hope I did okay. Thank you guys.